Alright, the next thing we're going to do is we're going to talk about frequency distributions in quantitative data. When we graph our frequency distributions, we use a histogram. There is one small difference between a bar graph and a histogram. Difference. I cannot spell, and I swear I'm college educated. Alright, so one small difference. So we're going to look at the example on page 49, example 2.8, of examples of management aptitude scores. The small sample was taken from 20 people. And in order to construct a frequency distribution for a quantitative data set, we need to determine several things: lower class limits, upper class limits, class width, and number of classes. So lower class limits are the smallest values in a category, and the upper class limits are the largest values in a category. The class width is the difference in between these two, and the number of classes. So we have 20 data points ranging between 77 and 99, which gives us a difference of 22. This will come into play later in the next slide. And we want our classes to show the variability of the data. There's no set science in determining what classes you can use or how big your classes need to be, as long as they follow the simple rule of showing the variability of the data. Well, that leaves a lot of room for interpretation. But for this case, we have a small data set, so we can use 4 or 5 classes because they both divide into 20 nicely. I'm going to choose 5 because that's what your textbook uses, and I want to, stick with what your book says. Also, if we choose 4, our class widths are going to be bigger, and it might not show the variability as nicely. So we need to ensure that the classes are not empty or nearly empty. There's no point in having an empty class unless it's actually in the middle. But then you can tweak your classes to eliminate that gap. In a small data set such as this, we can have just one element in a class. In larger data sets, we really shouldn't. We should be able to group the data in such a way that our classes are not nearly empty. So we know the range of the data is 22. We chose 5 classes because we can actually break up 75 to 100 in 5 classes nicely. And our class width is just going to be our range divided by the number of classes, which is 4.4. If this was 4.5, we would make our class width 5, but we're going to make our class width 4. Starting at 75, we go to 79, 80 to 84, 85 to 89, 90 to 94, 95 to 100. You could also use 99 here. That's okay. I just chose 100 because I want nice, round, happy numbers. So moving on to the next slide, we add our counts to each class. We add 3 from 75 to 79, 8 from 80 to 84, 85 to 89 is 6, 90 to 94 is 2, and 95 to 100 is 1. If we chose 4 classes with a range of 5, or not 5, it would probably be 22 divided by 5, which would be, 22 divided by 4, which would be 5.5. So we would have a class with a 6. This right here, this data right here would be lost. Okay, that didn't work. The 8 and the 6, that variability would go away if we were to choose bigger class sizes and a smaller number of classes. So 5 is a really nice fit for this particular data set. And then we construct a histogram for this. I'm going to change the pen color for this. All right. Notice that I actually remembered to put in a y-axis label here. All right. A histogram varies from a bar graph because here this is a continuous as opposed to discrete. Okay, so it needs to represent all the data sets, all the data points. We have our labels. Now histograms the bars absolutely have to touch. You can't have any spaces here. They need to be of equal size, and they absolutely need to touch. And that's the one minimal difference between a bar graph and a histogram, is that the bars touch. I could also do a a frequency polygon on this, where I would mark the midpoint of each bar and connect them. I do talk about briefly in constructing a bar graph by hand. This is just another way of representing data. I'm going to change the color of my pen. We'll make it blue. So it would just be connected in a straight line to each of the midpoints. It's just another way of representing data. Bar graphs are more friendly than dots and lines, but this is another type of graph. Of course, you wouldn't actually do it with the bar graph on top, but I'm just showing you another way of creating a histogram.